Hey, this is Team Datalab, and this year we came up with an agent we call Guillemot. And the purpose of Guillemot is to fit X-ray diffraction patterns. Fitting X-ray diffraction patterns is the way that we know what materials we make in the lab. And it's hard to automate because it's a very manual process. We're trying to fit a model to our data to come up with the best structure, but oftentimes if you just let things refine, it's not like a linear regression. You'll get caught in local minima or come up with something really non-physical. So whenever we're doing these fits, it's a very iterative process of looking at the fit, making changes, looking at the fit, making changes. So we wondered if large language models with vision could actually automate that process for us, not just automating the refinement, but actually looking at the result and gauging the quality. So here's what we came up with, and I will run it in fast speed because it takes a little while. So what you're seeing here is a tool calling agent written with Pydantic AI that has a whole bunch of tools specific to Rietveld refinement that we've written. The first is to find structures from structural databases. We use Optimade to be able to query online databases for all materials, in this case, that have manganese and antimony is what it decides to look for. And when it finds ones that he thinks are likely, it will write an input file for Topaz, and it'll actually run the third-party Topaz software to do a Rietveld refinement, make a plot, look at the plot, and then summarize what it thinks about the next steps. Okay, it gives us quite a lot of information, including how good or bad the refinements are, a summary of what it's done. It raises a few potential issues, such as an extra peak that may be related to an impurity. It suggests that it could make more plots for us, which we've given it the tools to do, and also suggests searching for impurities and asks us how we'd like to proceed. So we'll tell it to continue refining, checking for additional impurities, and we go on and it will create additional files. Now this can be an iterative process and it can go on for quite a long time. So we're excited about applying this in the future. Thank you very much.